All right, here we go. One last time. Let's go ahead and look at the lovely garden problem. Okay, word problem, so I'm sure all of my lovely students took a look at this and did this for their homework. I'm sure. Let's make this a little smaller. All right, that'll work. That'll have to do. That'll do, pig. That'll do. All right. So let's take a look at Lupe and her garden. All right. Lupe has a rectangular garden. The length of the garden is 2 feet less than 3 times its width. What? Okay. So Lupe has a rectangle garden. The length of the garden is 2 feet less than 3 times the width. So the length is, okay, so tell me what the length is. All right. So write 2 variable expressions for the dimensions of the garden. So let me tell, what is the length? Okay, so the length is 2 feet less. So it's smaller than, so it's 2 less than 3 times than 3 of the widths. Okay, so the length is 2 feet less than 3 times the width. So that's the length. The length is that. So the length is 3 W's, so 3 times the width minus 2. All right, cool. So how long is the garden then, or how long is the width? Well, the width is W for width. How convenient is that? All right, cool. So that's what we have. You could also use x here, 3x minus 2 and W equals x. That also works. All right, so if you were told that the area of the garden is 96 feet squared, all right, so the area is 96 feet squared, how could you figure out what the dimensions of the garden are in feet? Okay, how can we then find out what the dimensions are if we know what the area is? Explain your steps, describe what you know, and how you can use that information to figure out the actual dimensions of the garden. All right, so we're just going to talk through this because the problem is going to ask us to then do it in problem C, is to actually what are the actual dimensions. So I think what this problem is asking for is looking at, well, if you know the length and the width of the garden and the area, I know that the area is length times width. So if I know what the length is and I know what the width is and I know what the area is, I can solve for W here using our little area formula for a rectangle. All right. My guess is that since this is a quadratic question where we'll have some factoring or some other lovely stuff to do, but basically if I use the length as 3W minus 2 and the width as W and the area is 96 feet squared, I can multiply these two things together and then solve for W. And then that'll get me also what the length and the width is in feet. So that's the plan. Multiply the length and the width, set it equal to the area, and then solve for W here. All right, let's go ahead and do that. So what are the actual dimensions of the garden? Well, we know that the area equals length times width. We knew that the area was 96 feet squared. The length is 3 W's minus 2. And the width is W. All right. If I multiply this together, I can distribute here. I can say 96 equals 3W squared. And W times negative 2 is negative 2W. All right, so if I have a quadratic here, this is a quadratic equation. I want it to equal 0, so I can fix that pretty easily by subtracting 96 from both sides. So I now have 0 equals negative 3W squared minus 2W minus 96. All right. From here, let's go ahead and identify what A, B, and C are. Our A value, B value, and C value. A is negative 3, B is negative 2, C is 96, A, B, C. Go ahead and do the diamond now. So A times C, holy smokes, what is that? Let's see, 96 times 3 is 8, is 1, 27, 28. A negative times a negative is a positive, 288. That's going to be fun. That's going to be a lot of fun. All right. And then B is negative 2. All right, so we are looking for, so I actually had to pause the video for a second. You probably didn't catch that, but I was looking at this and I was saying there is not going to be any two numbers that multiply to make 288 and when added together make -2, because the only way to make a positive number up here would be two positives or two negatives. And there's no way that two numbers that multiply to make 288 are going to add to make -2. They're just not going to work out. So I went back and realized that my a value, I don't know why all of a sudden my a value went from 3w squared to -3w squared. So let me fix that here. That should make this better. So now a 3 times a -96 is a negative now. All right, what I do know now is that one of these has to be positive, one has to be negative. I'm looking for numbers that multiply to make 288 that have a difference of 2. So I'm looking at two numbers that are pretty close. So you can list out all the factors. You can start with 1 and 288. You can do 2 and 144. You can see if 3 divides in evenly. You can see if 4 divides evenly. So I'm going to pause the video for a minute, figure out what those two factors are, and hope that you do too. All right, so what I was doing is I was taking numbers that divided evenly into 288. I tried to see if 14 divided evenly into 248. I can't remember if it did or not. It didn't. I took 288 and divided it by 16 and got 18. So I said, well, does 16 times something equal 288? And it turned out it did. That 16 times 18 did. And that's what we were looking for. 16 and 18. If the 16 was positive and the 18 was negative, we would be in business here. 16 times -18 equals -288, and when I add them together, you do get -2. So that's what we were looking for, 16 and 18. So we did all that work so we could take this middle term and split it up into these two terms. Now we've got 4 terms. So I'm going to take all this stuff and I'm going to rewrite this. I'm going to rewrite this as 0 equals 3w squared plus 16 w's minus 18 w's minus 96. So remember, I took this middle term and split it up into these two. All right, so from here, now we just got to do our little box. Let's do that. Oh yeah, box time is the best time. You get the box, yeah, and you put the 4 terms in it. Oh yeah, that is the way we do it. All right, there we go. So now we got this 4. What is the greatest factor we can pull out of this top row? Well, can we divide them both by 3? No. Can we divide them both by w? Yeah, we can. So let's take a look now. W. So w times what makes 3w squared? Well, 3 needs to go in there. And w, 3w. And let's take a look here. 3w's times this. What has to go here? What times 3w's makes -18w's? Well, maybe like a -6. Shaw, that's going to work. 3w's times -6 is -18w's. All right, looking up here. What needs to go up here? W times what makes 16w's? Well, I'm pretty sure that's 16 there. All right, 16 times w is 16w's. So last question is, does 16 times -6, do a check. Does 16 times -6 equal -96? Yes, it does. All right, so what that then does, I'm going to take this, I'm going to move it over, because I'm going to run out of room here. Move this over. Move this over yonder. Okay, so what this now does is this is going to allow us to find what w equals. So we're going to have that the width of this rectangle can be found by these two factors here. All right. If I solve, one of these is going to be the value for w. So if I solve for w here, I know that one of these has to be 0. So I know that 3w plus 16 could be 0. And if I subtract 16 you get 3w equals negative 16. And if I divide both sides by 3, I'll end up with w equals negative 16 thirds, or negative 5.3 repeating, And that's in feet. So the width of the rectangle is negative 5.3 feet. Okay, that doesn't really seem to make a lot of sense. We'll come back to that. So here, or w minus 6 could be 0. Well, if I add 6 to both sides, we get that w could equal 6 feet. One of these does make sense to me. The other one doesn't make a lick of sense. That's because it's not a viable solution in our real life scenario. So what we do have is that the width of the rectangle is in fact 6 feet. This one just doesn't make sense. How can you have a length that's negative? So I'm going to cross that one out. This does become the width of our rectangle, though we're not done. If we take a look here, it asks what are the actual dimensions. So we need to know what the length is and what the width is. Turns out we already know one of them. It turns out the width is 6 feet. And the length was what? It said 3 times the width, but 2 feet less than that. So the length is 3 times 6 is 18, minus 2 is 16 feet. There you go. There's the garden problem. Hope you had fun doing that one. All right, catch you guys later.